So I'm going to do, you did a lesson on Cartesian plane last week. I'm going to go over the Cartesian plane, and then I'm going to put it together with finding the rule. So Cartesian plane, I'm just using page 52, and I'm looking at the Cartesian plane, is broken up into 4 quadrants. Quadrant 1, quadrant 2, this is just review for you guys, quadrant 3, and quadrant 4. You learned this in grade 7, and we reviewed it last week. We said that in the middle here, where the x-axis and the y-axis meet, so this horizontal line, known as the x-axis, and this vertical line, known as the y-axis, where they meet, is called the origin. And the coordinates here are 0, 0. Today, I am going to place my coordinates in a table of values. So please note that a table of values, also known as, instead of me always writing table of values, I'm going to write TOV, known as my table of values. I'm going to place my coordinates from my Cartesian plane in a table of values. Now, if I look at page 52, the table of values looks like this. It's a beautiful rectangular box. It's cut up like this. We have my x's, we have y's, and then the coordinates are in my table of values. So I'll use what they gave me. They gave me -3, -3. They gave me -2, -1. They gave me -1, 1, and they gave me a 0, 3. So they gave me the coordinates in a table of values. And they usually say, hey, can you plot the table of values onto your Cartesian plane? So you would have to know how to do that. So are you able to do -3, -3? Remember that the first number is always x, meaning that it's on this line. And the second number is always y, which means you're going up and down. So I start at the origin. And I'm going to do the first one. Let me call it A so that we can label it. We'll go A says to go -3, meaning this way, and -3 meaning going down, -1, -2, and -3. So that would go 1, 2, 3, 1, 2, 3. A would land right here. And you would label that little dot with -3, -3. And if they ask you questions like, hey, what quadrant was that in? What quadrant was those coordinates? You would say, oh, quadrant 3. Easy? Let's try -2, -1. -2, arch 1, 2, -1, right here, B. And then you would put the coordinates of -2, -1. And the next one says -1, 1. -1, and now this time it's going up. So this is 1, 2, 3, -1, 1, right here. This is C. This would be this one here, -1, 1. These are the coordinates there. And we'll do one more, 0, 3. These are the ones that get kids confused, 0, 3. 0, 3. So they'll go right here and they'll put it right here. 1, 2, 3. Oh, miss, right here. Am I right? No, because 0 means that you're not moving right or left, but you are going up 3. So this doesn't go here. This is a common mistake. This is one of the common mistakes I always find. So it goes 0. Oh, it'll move. 3. Up, 1, 2, 3. It's actually here, your 0, 3. What would this one be? What would this one be? 0. Easy to make a mistake. So those are the ones you just have to pay attention. This would actually be 0, 3. 3, 0. See how easy it is to make a mistake? 1, 2, 3, and then you're not going up and down. Good? So are the ones that land here in a quadrant? No, they're on an x-axis. If they land here, are they on a quadrant? No, they're on the y-axis. If they land anywhere in here, quadrant 1, anywhere in here, quadrant 2, 3, and 4. Anything else that you want to know maybe about the Cartesian plane? We're good? Okay, Cartesian plane, table of values. Table of values. I'm going to erase this because our next lesson has to do with table of values and finding the rule. You ready? It's not that easy. So I'm erasing live. I'm erasing. Are you in your notebooks? Take out your notebooks. Please write this is your title. Finding the rule. Finding the rule. It has to do with patterns and sequences that you learn in elementary. So if I told you, watch this, the first has 4. In the second, we have a 7. In the third, we have a 10. And I asked you, hey, what would happen in the fourth column? What would happen in the fourth? So we're like, oh, so you're in grade, let's say you're in grade 5, and you're like, oh, miss, I see the pattern. What's going on? What would you say? You're adding 3. You add 3. Oh, look, I added 3. Oh my God, I added, oh my God, I know it. This must be 13 because we're adding 3. Well, what we actually have here is a table of values. So let's show you the table of values. I'm like a magician. Are you seeing it? It's coming together, the table of values. All right, so now the table of values actually is in a horizontal position. Could have I made this table of values look like this? I could have, right? They mean the same thing. 1 and 4, 1 and 4. 2 and 7, 2 and 7. 3 and 10, 3 and 10, and so on and so forth. So table of values in a horizontal position, table of values in a vertical position. I can make it fancier and close it up. This is what we looked at earlier. I can make it fancier and close it up. Are we okay? Just making sure that you don't get confused over the look of my table of values. And what are these numbers in the table of values?
Constant.
Coordinates. My coordinates from the where? Where did I get them from? From the Cartesian plane. Can I plot this? Yes, I can plot these on a Cartesian plane. I'm going to give you another pattern. So on the first, I have a 5, then 2, a 7, and then in the third, I have a 9. Can anybody tell me what happened in the fourth? In the fourth, what's going to happen? What's going to be the fourth? What's the fourth one going to be? It's going to be 11. Do you understand where she got 11 from? Oh, it's going by 2, miss. I added 2. Add 2. So the difference was 2. Oh, I'm going to add 2. How about in my 7th one? What would it be here? Oof. What's going to happen in the 7th? So some of you are going, okay, on the 5th there's 13. And the 6th is 15.
13?
Not 13.
Oh.
We're in the 7th. We're not in the 5th. The 5th would be 13. 17. So what were you doing? You were writing 5 is 13, 6, right? You were kind of going like that. So now this would be 17. You're right. How about if I asked you for the 100th? Now it might take you all of your tests to do this, right? So you're sitting there doing a test and you're like, oh my God, miss, why are you doing this to me? Some of you are like, forget it, I won't even do this question. Yes, Dennis? Is it 203? You might be right. How did you get 203?
I took the, there's 93 left until you go to
It's very good. Okay, so the way that I'm going to show you this is to find the rule. If you can find the rule, then you can find any of these without counting each one separately. Okay, so let's try to find the rule. This is how to do it. You ready? You ready? Everybody's looking in front. You ready? To find the rule, to find the rule, to find the rule, you need to find the common difference. So the common difference is what? 2. So we write 2, checks up, you ready? X, I'm going to leave a space because I'm missing the constant here. I'm missing the initial value here, equals y. Okay, I know it makes no sense yet. Do I have any xy's? Does anybody see an xy in the table of values? There's a lot of xy's because these are x's and these are y's. Does anybody see xy's? xy, do you see that one? xy, do you see that one? xy, well you could use any of these. So let's pick one. Let's pick 1 and 5. 2, and I need to replace that by the x, and I need to replace the y by the y. So which one are you going to choose, 1 and 5? Can we choose 1 and 5? We're evaluating. We're replacing the variable by the value. We're going to choose 1 and the 5. Now, this is an equation. Let's make it true. 2 times 1 is? What do I need here to make this true? Plus 3. Plus 3. Yes? 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 Somebody's learning. At least there's somebody learning in my class. So this plus 3 is my initial value. Check it out. Plus 3. We just found the rule that belongs to this table of values. What does it mean? Well, it means that every time I replace the x, I'm going to get the output of y. So 2 times 2 is? 2 times 2 is 4 plus 3 gives me the y. 2 times 3 is 6. Yes. Plus 3 is, unless it's dressed down, I don't know about it.
No, it's not dressed
2 times 3 is 6. Plus 3 is 9. Yes? 9. Sorry, I'm just videotaping,
That's
so I'm
okay,
just going to
that's
finish this lesson. 2 times 4 is? 2 times 4 is 8. Plus 3 is? 11. So was he right in the back to give me the 203rd? Well, let's check. 2 times 100 is 200 plus 3 is 200. He was right. Now, he didn't do it the same way, Dennis, right? You didn't do it the same way as me. But he did get it. This is how you would get every single answer. No matter what I ask you up here, you'll be able to get this. Now, if you are confused, it's okay because I'm going to do 10 more, and then we're going to solve everything. Everything. But it's not that difficult. We just have to follow a couple of steps, and I could even write out what steps. Find the common difference. Leave a space. Evaluate with x and y. So part 2 coming up. All right, we're back. We're back. I know the first time you see something like that, it's not easy. I'm going to give you, ready? I'm going to give you another example. 1, 2, 3, 8, 11, and 14. So what's the first step to do? First step. First step. Write this down. First step is to do what? First step is to Common difference. I love the words you use. So the common difference. Find the common difference. Boom. Let's find it. And it has to be going up by the same amount or else you cannot find the rule. So it has to have a common difference or else it's not possible. Yes. 3. So it's actually plus 3, right? So 3. Second step. Second step. I want you to, so here we find the common difference. Cool. Boom. Done. Second step. I want you to write with the common difference 3x space equals y. So set up an equation. That's your second step. Set up an set up an equation. So this is what I mean by set up an equation. Step 3, third step. Boom. What do we do on the third step? What am I going to do? Replace, evaluate, whatever words you want to do. Replace x and y with any of the coordinates you see there. With any coordinates you wish. See? You get a wish today. You wish. So these are coordinates. 1 and 8, 2 and 11, 3 and 4. So here, look, I'm even putting x, y. I'm even setting up. You can add the lines to this. You can put the x, y so that you don't forget. So which coordinates are we going to use? 1 and 8, 2 and 11, or 3 and 14? It's your choice. It's your choice. What would you like? Somebody, anybody, choose 1 and 8, 2 and, because that's all going to give me the same answer. Because what am I looking for? What am I looking for? This little piece of the puzzle. That's the only thing that I have left to find the rule is this little piece of the puzzle. And how do I find it? By using one of these. This is actually the initial value that I'm looking for. It's called the initial value. I'm looking for the initial value. And I'll tell you what the initial value is later. Right now, who can find that piece? Can somebody tell me which x, y they used? Yes?
Well, I used 1 and 8.
Good.
And I got 5.
Okay, so 3 times, he chose 1, and he wanted it to equal to 8. So what's missing?
It's plus 5.
5 is missing. Plus 5, 3 times 1 is 3, plus 5 is 8. So do I need this now? Do I need this? Do I need this? No, I use this to find this. Could have I used 2 and 11? Yeah, 3 times 2 equals 11. What's missing? Plus 5. Plus 5. Oh, I don't like the numbers 2 and 11. I want 3 and 14. Okay, 3 times 3 has to equal to 14. Oh, there it is. Plus 5 again. So it doesn't matter which x, y you use, because you'll always find the initial value, which I'm going to stick right here. Do I need any of this? When you're doing a test, am I going to erase it? No, I'm just going to scratch it out so that I know, oh, Miss LaPena is going to be so happy to see that I used her method to find the initial value. Good. We will do at least another 5 examples. Definitely at least another 5 examples. So the fourth, so I have the first step, the second step, the third step, the fourth step. Well, what should we write on the fourth step? What we replaced that, so we did that. And we found the initial, thank you, value. Boom! 4 steps to getting this rule. I'm going to do another one. So I'm erasing. I'm going to leave the 4 steps. And I'm going to squeeze in here. And I'm going to put another example. So let's say I do this. X, Y, 1, 2, 3. And now look at what I'm going to do. 11, 15, and 19. So this is another example. What example are we on? Example 3?
4.
We're on the 4th? Are you sure?
3rd.
3rd example. We're on example 3. We're example 3. What's the common difference here? What's the common difference? Yes?
4.
It's 4, so plus 4 is my common difference. So I did step 1. I'm going to place the x space equals y. Is that what you're doing? And then I'm going to choose either 1 and 11, 2 and 15, or 3 and 19. Which one did you guys choose? Which one will you choose? Which x, y will you choose? I need an x and I need a y. Here's one of them. Here's another one of them. Which one will you choose? 1 and 11, 2 and 15, which one? Sure, 2 and 15. Let's choose 2 and 15. By replacing it here, will give me what? What will it give me? My initial value. So let's do it. So I'm going to take 4 times 2, space equals 11. What will make this true?
Miss 15.
15. Thank you. What will make this true? What will make this equation true? Plus 7. Now, if anybody used 1 and 11 or 3 and 19, you will also get the initial value of 7. All I'm going to do now is put a few more examples because it's not that easy. And the only thing that will make it easy is practice, practice, practice. So let's do a few more examples. And then I'm going to add another level of difficulty to it. So let's start off with example number 4. Okay, we're still in our notes. I know some of you are getting it, but it's not that easy. So let me give you, again, x and y. I'm giving you a table of values. 1, 2, 3. Let's try 3, 8, and 13. See if you can do this rule. Find this rule. So the first thing I need is to find my common difference. So the common difference here is 5. So I'm going to put 5x space equals y. 5x space equals y. I'm looking for the initial value. So which x, y will you use? Which x, y do you want to use? Go ahead. Yeah.
Oh, 1,
Perfect. So 5 times 1. Does everybody see where he gets the 1 from? He's getting it from here. Equals, where does he get the 3 from? Here. So he used the x, y coordinates of 1 and 3. 5 times 1 is 5. What equals to 3?
-2.
Minus 2. So we put minus 2 here, and we cross this off because we used it to find the initial value of negative 2 minus 2, whatever you want to call it. This is the rule. So if I say, hey, the question is, find the rule for this table of values, you would say, Miss, the rule is 5x minus 2 equals y. You know what some of you will say to me the rule is? Guess what some of you will say the rule is? Usually they'll say it's plus 5. Miss, the rule is plus 5. All I have to do is add 5. But that's not the rule. The rule has to look like this. Could it look like y equals 5x minus 2? Could it look like this? Yes, these are the same. Some tests will have it like this. Some teachers write it like this. Don't get scared. It's the same thing. So this is the way that I like it, but it's not wrong this way. Now, I want you to know where the initial value comes from on the table of values. Do you know where this minus 2 comes from on the table of values? I'll give you a hint.
5.
What? Where?
It starts from, let's see, the 0.
Exactly. So it's at the 0. This is your initial value at 0. So can anybody tell me what's missing here? Yes? Not 0.
You minus 3 by 5 gives you negative 2.
Very nice. Guess where my initial value was hiding in the table of values?
Under the y.
Where was it hiding? At the 0.
0.
At the 0. So sometimes the question will be really easy because you'll have a table of values. Let's say this is my table of values, x and y. And you'll have 0 is 4, 1 is 6, 2 is 8, 3 is 10. And I ask you, find the rule. Find the rule. Find the rule. Well, same thing. What's the common difference? 2x space equals y. How did I find my initial value? How did I find my initial value? Yep. I used to use one of these, right? Right?
Yeah.
To get this, right? Well, right now, I don't need this. Why? Why don't I need to do 2 times 1 equals 6? Why don't I need this to get plus 4 here? How come I don't need to do 2 times 2 equals 8, which is plus? Why don't I need this or this? Why? Why? Yes? It's right here. Woohoo! I'm here, look, at 0. I am the initial value. I'm plus 4 at 0. So why did I teach you this long method? Why did I teach you this long method? In case 0 is not there. Could you say, well, miss, I would have just gone 1 back. Oh, 6 minus 2 is 4, so at 0, yes. But what if my table of values doesn't even come close to the 0? So I'm erasing everything. And I'm going to erase this too. Is that okay? Can I erase this? You're good? And I'm going to give you another table of values that doesn't even come close to starting at 1, 2, 3. So let's say it goes 7, 8, 9. 7, 8, 9, and I tell you 12, 15, 18. Now, will you work backwards to 0 to get your initial value? No, I would not work backwards till 0 to get my initial value. What would I do? I would do what Ms. LaPena said. Find the rule using those 4 steps. Common difference is 3x, space, equals y. Use any of my xy's that are on my table of values. I'll choose 7 and 12. 3 times 7 has to equal to 12. 3 times 7 is 21. Minus what to give me 12? Yes? Minus 9. That means that my initial value, if I would have gone back, boom, 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 would have been what here? Minus 9. This would have been my initial value, which I did not go in that direction to find it. I used that little trick. Yes? Final answer is 3x minus 9 equals y. This is the general rule. So what is the rule? What is the rule for this table of values? The rule, miss, is 3x minus 9 equals y. That's the rule. Now I can ask you a lot of questions with this rule. Hey, what if the x is 34? You'd say, well, then the y will be 3 times 34 minus 9 equals y. So I can get all kinds of answers using this general rule. There's one thing that makes this harder. One thing that makes this harder. Anybody can figure it out? What's going on here? 7, 8, 9. 1, 2, 3. What's going on?
Adding, but
Well, it's only going by ones. What if my table of value, are you ready? I'm erasing. What if my table of values doesn't go by ones? How about if I give you this table of value? Check it out. Here's my table of value. And I say, are you ready? Are you ready? 0's at 4, 1 is at 8, 2 is at 12, and 3 is at 16. Can you tell me what my common difference is here? What's my common difference here? It's not 4. Why is it? Oh, no, I'm wrong. Sorry. I meant to do this. I'm sorry. It was 4. How about if it was this? Sorry. This is what I meant. So now they're not going by ones, they're going, so what's the common difference? What is the common difference? What is the, I'll give you another chance. I changed it up, do you know? Yes, it's going by 2's. Oh my God. How did we get a common difference? It's not 4, the common difference. You can't say that it's 4. This is not the common difference. Why is it 2? I love it. I love it. It is 2. The common difference is 2. Why? Yeah.
Because it's like, if it was 1, 2, 3, then it would have been 4, but since it's by 2 on the first line, it's...
Right. So if you can see here, there's a 1 missing, which would have been halfway from 4 to 8. So it would have been 4, 6, 8, right? So how do I get the 2? Oh, I lost some of you. Your eyes are like leaving me. Are you still with me? Who's lost? Okay, where? Tell me where. Tell me where. Is it the common difference now? Okay, so let me give you a trick to find the common difference. Ready? When it's going by, look, here, what's the common difference? 4, right? Here, what's the difference? 2. So what the trick is, okay, now I'm going to throw like this beautiful formula that you're going to be like, what? It's the change of y divided by the change of x. Don't let this scare you. Don't let this scare you. What it means is, what did y go by? 4. What did x go by? 2. So what's the common difference? What's the common difference? This is where you get the common difference of 2, and then you write x equals y. Now I'm not going to find the initial value. What I'm going to do is do more of these. Just to see, can you find, using this formula, which is actually called the delta y, this is a delta, it's a little triangle. Does this scare you, this delta y divided by delta x? It just means this divided by this. This difference divided by this difference. The change in y divided by the change in x. I'm going to do 3 more examples like this. So look. Okay, forget finding the rule. Let's just find the common difference. So here's my xy. How about if I have 0, 5, 10, and 15, and on this side I have 30, 40, 50, 60. What's my common difference? What's my common difference? What's my common difference? Well, we need to find the difference in y. Was that what you were going to tell me?
Yeah.
Okay, so I need the difference in y, which happens to be what? 10, divided by the difference in x, which happens to be? Therefore, there's a common difference of 2. Good. So it's 2x space equals y. And then we need to find the initial value. So why did I not do this before? Why was I not doing this whole thing before? Yeah? Because I was going by ones. I was doing 1, 2, 3, 6, 7, 8, 9, 10. So I didn't have to divide by 1 because I was going to always get the same answer. But now that my x value is going up by something besides 1, I need to show you this. Now this is a huge lesson because I've showed you how to find the rule, how to find the common difference, how to find the initial value, how to now find the delta y divided by the delta x. What do you think is going to make our life easier?
Where did you get 10 over 5?
Where did I get 10 over 5? Where did I get 10 over 5? I love the fact that she's asking me that. You know why? Because there's a lot of kids here that might still not know, and nobody's raising their hands to tell me. So where will I get mad? No, I'd get more mad if you don't ask me the question. Where did I get 10 from?
She got the 10 from, because 30 plus 10 is 40, and so on.
So the change of 30 and 40 is where I get the 10. So the common difference here, 30 to 40 is 10, 40 to 50 is 10. So common difference, the change in y, that's what it means, common difference is 10. Divided by, remember this line means to divide, the change in x. What's the common difference in x? 5, right? So I got the 10 from here divided by the 5 from here. The 10 from here divided by the 5 from here. 10 divided by 5 means that there is a common difference of 2. Which makes sense, right? So if I were to rewrite this, I would get at 1, I would get 32. At 2, I would get 34. At 3, I would get 36. At 4, I would get 38. And at 5, I would get 40. So my common difference between 30 and 32 was where I get the 2 is my common difference. We do another one? Yes. Now I did finish that up. You should be able to finish that up with the lesson that I taught you. Let's try another one. Here's my xy. I'll do 6, 10, 14. And on this side, I'll go 20, 28, and 36. 36. Find the common difference here. So the first thing I would do if I were you is find the common difference here. 8. Find the change here, 4. And do 8 divided by 4. Delta y divided by delta x is 8 divided by 4. My common difference, my CD, is 2. x space equals y. Can somebody tell me what the initial value is? So that means you're gonna have to do a little work. Yes,
To find the initial value, would we have to do the original?
yes. Use 6 and 20, 10 and 28, 14 and 36. That's a great question. So we almost got lost in finding this whole common difference to how do I find the initial value? We're back to either choosing 6 and 20, 10 and 28, or 14 and 36. Now, my lesson is over. My lesson is over, but we definitely need some practice. Okay? And the practice will help you see, do I understand? Anybody know how to get the initial value? Yes, go ahead.
So I chose the 6 and the 20.
Perfect, 6 and 20. Does everybody see where he got the 6 and 20 from?
Yeah.
X is 6, Y is 20, and what's missing here to make this true?
So 2 times 6 is 12 plus 8 equals 20.
So that, do I need this?
No.
Nope. This was there to help me. What's my answer? This is my answer. What's my rule? This is my rule. How did I get it? By doing this step, this step, this step, this step, and getting my initial value. Initial value on a table of values is where? Where's my initial value in the table of values?
0.
At the 0. Is the 0 there? In this case, no. Could it be there? Sometimes it will be. In your homework, the first 5 are with zeros. You don't have to do this. Will it always go by ones here? Will it always go 1, 2, 3, 5, 6, 7? Will it always go up? No. Sometimes it'll go by 4. Sometimes it'll go by 2. Sometimes it'll go by 10s. Why? Then we have to use the delta y over the delta x. Yes.
Why do we need the triangle and the 804?
It's just the way that they write it, okay? It means change of y. What's the difference in y? This is what it means.
But in the end, you end up doing the same thing.
What do you mean by the same thing?
The fact that 2x.
Yes, but it's this that you would, this is what's important, is this 2. So you needed to do 8 divided by 4 to get that 2. Okay? Done. Today's class is over.